So here's Charles' law. We have a balloon, which is really cool. We put it in something that's really cool, and this is liquid nitrogen. Sorry, we don't have any to show you, but I'm sure you can look up some videos on YouTube. The balloon will actually shrink. Now, of course, the little guy's textbook talks about taking a balloon and putting it in the freezer, which, by the way, you can do at home. So if you take a balloon and you put it in the freezer, guess what? It's going to get smaller. And then you take it out of the freezer as it warms up, the balloon's going to get bigger again, which is very cool stuff. Literally. So here's Charles's law. V1 and T1 equals V2 over T2. What does that mean? That means that the pressure and the temperature have a direct relationship. This is the mathematical relationship. If we were doing math, we'd be plugging numbers in and solving. Lucky for us, we don't. All we need to do is we need to know that as the temperature increases, the volume increases. Makes sense. You heat something up, the volume gets bigger. Okay, let's see some examples. Here's some more examples. So here it is. So you increase the temperature, you increase the volume. Now wait, why does it say K there in temperature? Well, remember I were talking about Kelvin. It's proportional to the Kelvin temperature, not the Celsius temperature and not the Fahrenheit temperature, because if you use those, you might end up with a negative number, and that would mess up with a negative volume, and you really can't have a negative volume. But you can have a volume of 0. So the volume is directly proportional to its temperature. Temperature increases, volume increases. Temperature decreases, volume decreases. Good way to tell that is look at a balloon. You take a container, put a balloon on top, you put it in hot water, and the balloon's going to expand. Maybe I'll show that to you. Here you go. There's another picture over there. But of course, best way to think about it is think about popcorn. You heat up popcorn, temperature goes up, the popcorn goes up. Temperature up, volume up. Easy. Yes? Good. Now, of course, car engines, another Mr. I plug here, is that car engines, your car works on Charles's law. The fuel goes in, you have a combustion, it explodes, expands, increased volume. That increased volume pushes the piston, and then boom, 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 and now your car runs. Okay, so here's another picture. You take a piston, you push it down, and here's the piston goes up, depending on if you heat it or you cool it. And here's a little volume and temperature. Don't worry about that. Okay, here's Charles' law again. The temperature goes down, the volume goes down. So now wait a minute. I remember Inflategate many years ago. Another example based on temperature. You can have a slightly underinflated rubber tire. You can have a plunger on a turkey when it pops up during Thanksgiving. That's how it works. And of course, the football inflated inside, taken outdoors, will shrink slightly. Not as much as it did during that game, though. So, Inflategate, not true. I mean, definitely true. Okay, so temperature goes down, volume goes down, temperature goes up, volume goes up. Easy. Got it? They're related. Practice question. What would you do to reduce the what would you have to do to the temperature to reduce its volume by half? Obviously, you have to reduce the temperature by half. See? Easy. Next. If you want to increase the volume by 3, what do you do to the temperature? Increase by 3. Hello. If you want the volume to increase by 4, guess what? You have to increase the temperature by 4, or the volume by 4. Whatever it is, you're increasing it by 4. Easy stuff. Yes? Yes, I thought so. Next, Guy's Law. Guy's Law has to do with P and T, pressure and temperature. So it is also directly related, temperature and pressure. So temperature goes up, the pressure will also go up. Temperature goes down, pressure goes down. So whatever the temperature does, the pressure and the volume will do what it is. So here's some more examples. There's that popcorn again. So temperature goes up, the pressure goes up. So let's see. Oh my goodness, it's a volcano. Well, obviously volcanoes are hot. Yes, they are. So the temperature got really hot in the volcano and the pressure builds up and all of a sudden, kaboomy! Major explosion on a volcano, a small explosion in your popcorn. And of course, here's a chemistry picture with the way of measuring the gas particles. So here we have in the ice bath, the molecules are moving slower, and here the molecules are moving a little bit faster. Can you tell by the picture? Not the best picture. But here's an interesting factoid. For every 10 degrees, the temperature drops, the tire pressure will decrease 1 or 2 psi. So as it gets colder, the psi is going to go down on your tires. Very interesting. And of course, the opposite is the case. Ooh, that's nice bright yellow. I can really see that. So we have temperature goes up, pressure goes up. So for the fixed amount of mass, directly proportional, this is the technical term for technical definition. What does it mean in English? Temperature goes up, pressure goes up. The end. So here we have cold gas with little arrows and hot gas with bigger arrows. Easy. What would you have to do with temperature to reduce its pressure to half? Well, let's see. Pressure half means temperature half. Easy, right? Next one. Increase by 3 times. Didn't I do this like 3 times already? Yes, I did. Am I being redundant? Yes, I am. Did you get it yet? I hope so. If you want to increase the pressure 3 times, you have to do what? The temperature by 3 times. That's easy. If you want if the temperature is increased by 4 times, what happens to the pressure? It goes up by 4 times. Easy stuff. Okay, so here is the gas law. Oh, that was the end of the slide. Look at that. Here is the gas laws that you need to know, theoretically, so you can write them down for notes if you need to have them for a quiz or something. So Boyle's law is pressure and volume equals pressure and volume. The pressure and the volume are inversely proportional. Pressure goes up, volume goes down. That's the only one that's inversely proportional. That's Boyle's law. So pressure up, volume down. Charles's law, volume up, temperature up, or temperature up, volume up. And Guy's law, temperature up, pressure up. Now, lots of ways to remember the P's, the V's, and the Boyles and stuff like that, but I won't say it on the video in front of my wife. Okay, so, and little guy who, of course, would repeat what I'm going to tell you. Nice. Exactly. Because you know what stays in Mr. G's classroom. What happens in Mr. G's classroom stays in Mr. G's classroom. But when Mr. G posts it online, then it's out there in the wild, so I have to be kind of PG rated. Okay, so we got our gas laws. Know them, love them, memorize them. Just understand what's going on, and then answer the questions on the quizzes. And that is the end.